technology. So on that note, if you can't hear me or see me or anything goes wrong, just get my attention somehow. Anyway, it is an honor to be here. I am excited to see those of you who I can see, and I trust that those of you who I can't see are just as beautiful and wonderful. So as Mabel said, I built a boat called Seacharger, and it was about 4 years ago. And I'm going to talk about that today and share some lessons learned. So let me share my screen here. Okay. So first of all, a little bit about me. This is some pictures of my kids and my family. I am first and foremost a father and a husband of 4 beautiful children. And in my job, I have had a really good career, really fortunate to work on a lot of cool projects. I started off at a rocket company called Orbital Sciences, then moved on to working with unmanned aircraft, like the 2 you see there. And then my most recent job was at a company called Liquid Robotics, and we made a wave glider, which is an unmanned boat powered by wave action. And that's the thing on the bottom right there. And so let's just talk, as some background, let's talk about robots. So we've sent robots to Mars. This is a picture of the Curiosity rover, which I think is still alive on Mars. I could be wrong. And that's an actual picture from the surface of Mars, pretty cool. We've even sent robots out of the solar system. This is Voyager, launched decades ago, and it's now left our solar system. Those projects are cool, but they cost a lot of money. And I've always been fascinated by what you can do with only a little money. In 2009, I saw this project and it really caught my eye. This was a group of students on the East Coast. I think they were college students. They might have been high school though. And what they did is they took a weather balloon and a little styrofoam cooler, and they put some electronics in the cooler and a camera, and they launched it. And they let it go, and it went up about 80 or 90,000 feet, and then snapped that picture. And the total budget was something like $300 or $400. And so they essentially built a spacecraft. I mean, it basically got into outer space on a budget of $300 to $400. And I just remember seeing that and thought that was the coolest thing in the world. So that got me thinking, what could I do like that? And I thought about, well, what about crossing an ocean? And it turns out that people have been trying to do this for a while. These are 2 different projects, Scout and Solar Voyager, both solar-powered boats. And you can see in the little maps, Scout made it about halfway across the Atlantic. Solar Voyager maybe a third of the way before they ended up breaking. But I saw these projects and I thought, you know what, I want to give that a try. And so I got together with a friend of mine from church. His name is JT. And I knew he was the right guy for the project because he told me that once he had made a chicken coop that would feed his chickens automatically while he was away. And I thought, this is the kind of guy I need to help me. And so JT and I got together and started working out. We got a chalkboard and started planning out how the boat would look. And so that's where that's what leads to Seacharger. So there's a little picture of Seacharger out on the ocean. And I'm going to talk about sort of the development of how I built it. So first of all, very important on this, and this is especially true for you guys being young. I got to tell you, when you're young, you always try to make everything fancy, right? You want to make it full of features and like doing everything you can make it do. At least that's how I am. But as I get older, I realize that complex things don't work very well, usually. You want to keep it simple. So the KISS principle stands for keep it simple, stupid. And that's what I tried to do. So building this boat, I had pretty cheap equipment. I did a lot of work by hand, just, with a sanding block. to shape foam, and there was only one CNC part on the whole boat. The rest was just built by hand. I used a really old 2D CAD program, didn't even have SolidWorks or any of the 3D CAD. And you can see, I like this picture here, is the battery pack I was assembling on my kitchen stove top. So pretty simple stuff. I started out with the electrical system because really a solar powered boat is built around the electrical system. And so I got the basic components of the electrical system and put them on a cookie sheet just in case they caught fire, and connected them to a solar panel that I put on top of our roof, and just took some data to prove that I could charge a battery, run the battery during the night, and then recharge it the next day. I did learn one thing, and that is that solar panels really like to be cool. I went up on the roof one day and sprayed them with water, and you could immediately see the amount of power output go up. So that actually makes it really nice to have a solar powered boat, because they're constantly getting splashed by the water to keep them cool. So then I got into the mechanical part after sort of finding out, how to build the electrical part. And I made a lot of mistakes. And I like this quote by Thomas Edison. He says, "I've not failed. I've just found 10,000 ways it won't work." And so here's a few pictures of some of the ways that I failed. The upper left, I had a rudder where I used magnets to couple the motor inside the dry container to the rudder on the outside. And that just didn't work. They weren't coupled firmly enough. The lower left picture, I had that single strut which connects the boat down to the motor pod down below. It was too floppy, so I had to throw that away and try again. And then on the bottom right, it was just a belt drive for the motor. I ended up throwing that away and just doing a direct coupling between the motor and the propeller. So I actually spent a lot of time and a lot of money on making mistakes, but that's just how it goes, right? Another important thing on projects like this is to decide where to spend money on something you can buy and when to just make it yourself. And so like connectors, as Alex mentioned, are really hard. If you need them to be waterproof, it's really difficult. They can be very costly. And so on Seacharger, I decided to make them myself out of some brass plumbing fittings. That took a long time. I sort of wish I had just bought them, even though they were expensive. That yellow box there, that was an off-the-shelf, like a sunglasses case. It was only like 12 bucks. So that was my electronics enclosure. So that's a case where I could just buy something instead of trying to machine my own enclosure. The propeller was interesting. It uses basically a model airplane propeller, and those are typically made out of plastic. And if you put plastic in water, well, if you put nylon in water, it will actually absorb water and it will become floppy. And I learned that the hard way. And so I actually had to take one of these nylon propellers and pull a mold off of it and then build the actual propeller out of carbon fiber, which is really time consuming. And I didn't want to do that, but that's one I had to do. One more example, the anti-fouling paint. When you put something out on the ocean, the little barnacles love to grab onto it and they will slow down your boat. So they make this paint that is actually poisonous to the barnacles. I was a cheapskate, so I bought the cheapest paint I could. That was a bad move. Should have bought the good stuff. But anyway, so there's this constant consideration of where to spend money and where to go cheap, where to build your own stuff, where to buy it, and that makes it really difficult. But anyway, with some of those decisions made, I now had a working boat. It wasn't autonomous yet, but I could at least take it out on the ocean. So we took the boat out in Avila Beach up in Central California and tried it out. And it seemed to handle the waves pretty well, and it seemed to go fast enough. So then it came time to give it some brains. So these are the basic components that went into the boat. And what I did was I put these on a tray, like that plastic tray in the picture. And I programmed them to be an autopilot. In other words, to move the rudder to get you from where you are to where you want to go. And then I programmed a couple waypoints into them that were actually locations in a park near my house. And so I took this tray of components to the park, I turned it on, and I allowed it to guide me from point to point in the park. And the little rudder servo would move to show me which way to turn. And so I walked around the park with these electronics in my hand, testing whether they would get me from where I am to where I wanted to go. And once I was satisfied that they worked like that, I put them on the boat. And then I took it to a local lake I was living in Sunnyvale, California at the time. Took them to a local lake, and that first picture you see, the red box is where the boat was supposed to go. The blue lines are where it actually went. And you can see it pretty much worked, but it was a little bit wavy, right? And then I took it out a second try. I had adjusted some of the autopilot gains, took it out a second try, and you can see the second try is a lot better. So I knew I had a boat that could guide itself around. Now this was a lake, and I didn't know how the boat would handle the waves, but I knew at least it could, in principle, work. So then I had a working boat, but there were still a few details to work out. One of the big ones was if you did the math on the rudder. Now the rudder is a mechanical device that has to go back and forth over and over. And I figured that it would have to do at least, well, almost 2 million cycles if I was to make it from California to Hawaii, which was my goal. And typically one of the remote control airplane or remote control car servos is only good for 300,000 cycles. So I figured I needed a custom servo. And I enlisted the help of some friends. You see them there. I also needed a printed circuit board to put all the components together. And I didn't know how to do that. So I asked them to help me with that too. And so they did. And so they built that servo that you see there, and they built the circuit board. There was a problem with the servo though. It had the feedback device inside it's called a variable capacitor. And as you turn it, the capacitance changes, and you can use that as feedback for where it is in its position. The problem was it had a glitch in it, and you can sort of see on the curve there, that little bump in the curve actually ends up making it basically useless. And so I had to make a last-minute scramble to try to find a servo that would work. And it just so happens that at that exact time, a company had come out with a servo that would be able to last long enough. And the reason it would be able to last long enough is because it had a special motor, a brushless motor, which doesn't have any mechanical brushes inside to wear out. And the other thing it had was a magnetic encoder, which most servos have a physical potentiometer, which has a little wiper, which wipes back and forth on the surface. And that's usually what wears out. With the magnetic encoder, it will never wear out. So just at the time that I realized that the custom servo that my friends built me wouldn't work, this company came out with this other servo that would work. So I swapped out all of their servo and put in this new one. And that was very painful because they'd worked a long time on that servo. And I basically had to tell them I'm not using it, but you got to make those decisions. So it ended up working. So reflecting on the project, you know, when we started out, we were going to build 3 boats. We were going to get all these sponsors to give us money. And we were going to test the boats out on the ocean for a few days and bring them back and make changes and all that. Well, the way it really worked was we only had money and time to build 1 boat. Only 1 company sponsored us, which was a solar panel company. And I ended up not testing it on the ocean. And I'll get to that in just a minute, why I made that decision. So plans changed a lot. So now I basically had the boat built, and my brother encouraged me to take it to MakerFaire. And if any of you have ever been to MakerFaire, you know how cool it is. I went to the one up in the Bay Area, which is basically, I think, the biggest one. And so a lot of people came by. It was a lot of fun. And these are the questions they asked, and I'm going to answer these for you. So top 10 questions were, first of all, that's going to cross an ocean. Yeah, most people didn't think it would make it, and I didn't either, frankly. Number two, why don't you put a camera on it? The reason is that, first of all, it's really expensive to transmit an image from the middle of the ocean over satellite. Second of all, the ocean is really boring. There's nothing to look at anyway. Number three, where's the propeller? The propeller is really small. It's only about that big in diameter, and it's down on that pod that's hanging down below there. And most people didn't even notice it was so small. The reason it's so small is because solar panels don't make a lot of power. And so you can't power a big propeller, so the boat's going to end up going pretty slow. Number five, where do you sit? A lot of people didn't get the idea that it was a robotic boat. You don't sit on it at all. Number six, how fast does it go? It can only go about as fast as you can walk. So it's pretty slow. And at that pace, it would take about 40 or 50 days to make it to Hawaii. Number seven, what are you going to do with it when it makes it to Hawaii? I didn't have an answer for that because I didn't think it would make it. Number eight, how are you going to keep ships from hitting it? The answer to that is that the ocean is really big, right? And so the chances of it hitting a boat are actually really, really slim, especially once it gets a few miles out of shore or offshore. Number nine, what about the Pacific garbage patch? I guess there is some garbage in the Pacific, but I wasn't going in that area. And number 10, don't you think you should test it in the ocean a little bit? So here's my thinking on this. The second you put it in the ocean, it's at risk, right? It can be caught in kelp. It can be run over by a boat, especially, if it's close to shore. A shark could bite it. I mean, you name it, anything can happen. So my line of reasoning was, if I'm going to put it in the ocean, I might as well send it to Hawaii, right? Like, why waste time going up and down the California coast or just some other test like that? If it's there, send it to Hawaii. So that's what I did. So I'm going to play this little video. This is a video that this reporter came and made after seeing it at Seacharger or at MakerFaire. Whoops, hold on.
Humans have been making voyages across the ocean for centuries. But with the advent of GPS tracking and remote controls, you can now be a captain without ever running the risk of getting seasick. Meet Damon McMillan. He is the landside captain of the Seacharger, which is on a mission to become the first unmanned autonomous boat to cross an ocean using only solar power. McMillan and 3 of his friends started the project 2.5 years ago in his basement, but making an unmanned solar-powered boat was not always the plan.
We were inspired by a competition that they have every year where they send robotic sailboats across the Atlantic. And so far that's never been successfully accomplished. And we sort of started out on a sailboat and then shifted over for some reason to solar power.
The Seacharger is only about 7.5 feet long, but what it lacks in size, it more than makes up for in innovation. 2 ultra-thin, 100-watt solar panels power the ship, storing any extra energy in battery packs for use at night or on cloudy days. A satellite modem, GPS system, and some homegrown software give McMillan the ability to control the boat from hundreds of miles away. It's a system that'll need to work flawlessly if the Seacharger is to make the journey from California, across the Pacific, and into Hawaii.
There's very little I can do if something goes wrong, though. So it's just going to be a lot of monitoring it, keeping my fingers crossed, probably a lot of prayer, and just hoping that it does its job.
McMillan says he plans to launch the Seacharger on Memorial Day, May 30th. You can track the boat's progress online at www.seacharger.com. Ships ahoy!
All right, so just as there are people who are interested, there are also people who are critical. And these are some comments I got on the website. The first guy didn't really think it was a worthy project, I guess, because it doesn't carry people. The second guy, I think he did think that it was going to carry people. He says, I'm afraid that he might be another Coast Guard rescue if he's lucky. So I think he thought I would like ride the boat to Hawaii or something. But anyway, so there were critics, but the vast majority of people were really, really supportive. And that was a really cool part of the project. Also, I'd be remiss if I didn't mention that my family was a big backer of this project and big helpers, and supported me the whole way. These are some of the pictures, the background pictures, them when we launched it. And so 1 week after taking it to MakerFaire, we took it down to Avila Beach in California and launched it. And a couple of people came and showed up, and here's a quick video of it going out.
Here's Hagoth out in its first few moments, heading out.
And so you can see there, it looks really fast, but it's actually not that fast. So we launched it. Everything was looking good. We followed it out with a boat for a little ways, made sure it was going well, and then left it and went to lunch. And here's what happened. So you can see the red line there is pretty straight for a while. And then it hit a software bug. And basically it hit a line in software where I had tried to divide by 0. So lesson number 1, don't divide by 0. Lesson number 2 is that the reason it didn't hit that line of software before is that that line of software only came into play if the boat went more than 2 kilometers past the previous waypoint. And the importance there is I had never tested that condition because I had never driven the boat that far. And so I had some untested lines in the code. So there's a lesson to be learned there too. Anyway, what happened was the autopilot became useless, but I could still send commands to the boat, manual rudder commands. And what that was like was I could only send a command once every 10 minutes. And so I had to basically make a small change in the rudder position and then wait 10 minutes and see what effect it had. And that was very difficult. But eventually I sort of got it heading back to the coast. And it was headed right for this really rocky portion of the coast where it would have been totally obliterated. But at the last minute, the winds and the waves just sort of steered it to the right. And it ended up on Pismo Beach, which is really, really beautiful, sandy, flat, clean beach. And so it was alive to try another time. And so I took it home, I fixed the bug, got it back in the water, this time from Half Moon Bay. And this time it worked a lot better. So it went out and started heading towards Hawaii. And during that time, it would send me emails through a satellite link. And this is what an email looked like. It was just a string of numbers, but the numbers contained the latitude and longitude and battery voltage and all that stuff. And then it was posted to a tracking map so people could see where it was going. At first, it turns out that the coast of California is usually pretty windy. And so at first I was like trying to send the boat in the right direction to take advantage of the winds. I eventually just gave up on that and just said, okay, go straight to Hawaii. The boat had 2 navigational modes. One was waypoint tracking, which is like I just mentioned, where you say, go straight to Hawaii from your current location. The other is heading hold, where it tries to hold a magnetic heading. And so both of those came in handy at times, but usually waypoint tracking is the method that I used. And so it just kept going and going. And I was faced with this question of, okay, well, it might actually make it to Hawaii, so what do I do? So we hopped on a plane and took my whole family and we made a little vacation out of it. We arrived there about a week before Seacharger was going to arrive. And it just so happened that there is this gigantic multinational military naval exercise going on at the same time. That was pretty disturbing because we thought they would run over our boat. And the other thing was a tropical storm was bearing down on Hawaii, also at about the same time. Fortunately, the boat didn't get run over by the Navy boats, and it got there right before the tropical storm got there. And so here's just a quick video of it coming into Hawaii. It's pretty windy then. It had some high seas to deal with. Here's a picture of what it looks like from underneath. and another one from underneath. And so finally we brought it into this little bay on the big island. And I was really excited because everything was working. You know, the boat had gotten there. Well, the plan was to take over manual control using a radio controlled airplane transmitter. And for some reason that didn't work. And so the only control I had over the boat was still sending commands via satellite. But I had to do that using my phone, and my phone was dying. So I had to borrow my mom's phone and finally got it working. And I had to just send it a new waypoint on the island of Hawaii, which basically tricked the boat into just driving onto the coast. And right before it hit the coast, my wife jumped in the water and grabbed it, and then we pulled it out of the water, and there it was. And it was in really good shape. The only thing was it had a few barnacles attached, and one of the solar panels was sort of corroded. At least the wiring was. And so I fixed that. And here I was faced with the question of, what do you do if the boat reaches Hawaii, which I never had really thought about. And to put it in a box and ship it back would be really expensive. So we just thought, let's reprogram it to go somewhere else. And we chose New Zealand and sent it to New Zealand. So here's the second launch.
On the east shore of Hapuna, or of the island of Hawaii at Hapuna Beach State Park, getting ready to launch Seacharger again. This time, New Zealand or bust.
The boat did have a lot of fight left in it. And so it went off the coast of Hawaii. Here's a boat taken, or a picture taken from a boat after it left. Some more really high seas. And indeed, it just kept going and going and going. And on the way, it ran in, or they didn't run into, but it got pretty close to running into a couple of islands. I didn't even know they were out there. Turns out there's lots of islands out in the Pacific. So I had to give it some commands to avoid some of those islands. And it just kept going until it almost made it to New Zealand. About 400 miles short, it just started drifting. And what had happened was both the rudder and the propeller were broken. So something must have hit it. Maybe a log, maybe a shark, if you want to think that. I prefer to think that because, you know, it makes it sound cool. Anyway, so it was adrift, and I thought, okay, it's over, right? There's no way I'm going to get the boat back. Nobody's going to get in a boat and go pick it up because it's 400 miles away. But my mom, she got out, you know, essentially a phone book. She found some numbers on the internet somewhere and started calling shipping companies. And she found a shipping company that had a boat that was running to New Zealand. And they told her, yeah, you know, if you send us the coordinates of your boat, and if all the conditions are right, we'll try to pick it up. And so this is their ship, and this is not a small ship. This is like a full-size container vessel. And I emailed them every 10 minutes the position of my boat. And so they intercepted it. And at one point, they actually even had to turn this boat around to sort of position themselves, which is really amazing that they did that. And then they sent this guy over the side of the boat to go pick it up. And they pulled it out of the ocean, and you can see it's just covered in barnacles, and I think there was even some fishing net on it. And they cleaned it up, and they actually had to smuggle it into New Zealand, because New Zealand is really strict about their environmental laws and all that. Anyway, so they packed it up in cardboard, smuggled it in, and this is what it looked like. It had a bunch of dents and scrapes, and so it had been through a lot. And then a guy I knew in New Zealand took care of it and took it to a museum there, and it spent 6 months in the museum. And so when all was said and done, the boat ended up going about a quarter of the way around the world and was out on the ocean 155 days. And so I thought about this, you know, I mentioned before, there are a lot of really supportive people and a lot of people following this boat from all over the world. And I thought about, you know, what makes it compelling? Why were people interested in it? And I think one is that it was a maker project, not commercial. In other words, I wasn't trying to make money off of it. I think number two, it was prolonged and trackable and sort of nail biting, right? It didn't just last for a few minutes, all right? You could get up every morning and check on it. And number three, it had a low chance of success, and that's definitely true. And I just got all these really, really supportive emails from all over the world that were really cool. And that was just, it was an aspect of the project I had not foreseen, but ended up being really cool. And so lessons learned, if I had to do it over, what changes would I make? Number one, I would have put some kind of payload on it. I mentioned before that the ocean is boring and there's nothing to take a picture of, but still it would have been cool to have a couple of pictures from the middle of the ocean. I would have changed the design of the hull to give me more solar panel area and also make it more resistant to tipping over. This boat was always tipping to one side, you know, depending on the wind. Number three, of course, the more robust rudder and propeller, because that's what broke. Number four, better anti-fouling paint. You saw how the boat looked when they picked it out of the water in New Zealand. It was covered in barnacles, so better paint would have gone a long way there. Number five, more batteries. Number six, more expensive motor. Those are just to make it go a little bit faster. Number seven, more modular and repairable. I actually have the boat right now in my garage, and I can't do anything with it because it was built for a one-time use. If I were to try to change the battery pack, for example, that would require like actually cutting open the boat. And number eight, I'd love to make one that's smaller, something you could fit in your suitcase that could still cross an ocean. I don't know how possible that is, but it's a goal. And so more generally speaking, what lessons do you learn like about life or about engineering in general from this? Number one, take a risk. I mean, you hear this so much, especially from older people, that it sounds like a cliche, and perhaps it is, but it's so true. You know, this boat was a risk for me because I spent a lot of time and money on it. And by the way, those friends that I mentioned earlier, they helped too. I don't want to make it sound like it was all my time and my money. But anyway, it was a big risk. It did have a low chance of success, but that's where the reward comes. Number two, ignore the critics, including yourself, right? I mean, you can sometimes be critical of yourself, but other people as well. Number three, do what you love, not what makes money. If you're fortunate like me, you can make money doing what you love also. But I think priority number one is to do something you love. And I obviously love this project and had a lot of fun with it. And number four, ask and it shall be given you, seek and you shall find, knock and it shall be opened unto you. That's a Bible verse, and I can assure you that I spent a lot of time asking God for help. And I know for sure that he gave me help throughout the project. I also asked for help from other people and received it. And so just as a kind of epilogue, 2 years later, somebody crossed the Atlantic with an unmanned sailboat. And so a lot is going on in this field of unmanned boats. And I think as I say here, interest is growing among both individuals and educational institutions. I think the challenge of this kind of project is that it's multidisciplinary. And a lot of people that are approaching it, they come with only one set of skills, like a software engineer with only software skills. And you sort of have to know a little bit about everything, although obviously you can learn. But that takes you to my third point here, which is the hard part about learning about how to do this is that you have to know what you don't know. So for instance, galvanic corrosion is a good example. Like, how many of you knew that if you have a carbon fiber piece and a stainless steel piece in contact with each other, and you put them in the ocean, the stainless steel piece will corrode away? Like, that's not very common knowledge, but it turns out to be really, really important for a project like this. Now, if you know about that, you can just Google it and find out what to do about it. But if you don't know about the problem, it's difficult. Another challenge is at this point, you have to make a lot of the components yourself. You know, this boat was mostly home built. In the past 2 years, I started a company called Blue Trail Engineering, and I'm making some of the components that I had to build by hand for Seacharger. For instance, the connectors, the thruster motor, and that rudder servo. I'm making those so that other people can do projects like this and not have to spend so much time on those. But it's still a lot of handmade stuff. But again, the reward for doing something like this is just tremendous. And I can't even explain how rewarding it's been, both professionally and personally and just emotionally, like every way. And so that is the presentation. So if you have any questions, I'll take them.